Our second keynote today is Suresh Mathew. Where are you? Oh, he's getting a microphone. Excellent. You all know him as the CEO and the founder of Sedai. Today, he's going to share the vision for the new era of the cloud, including top secret AI tools that the team is building. Do we swear people to secrecy? How do we maintain that? We'll tell you, but then we have to kill you. I'm not sure how that goes. As you all know, at Sedai, Suresh and the team are focused on rethinking how engineers manage modern cloud infrastructure, less reactively and more autonomously. Prior to founding Sedai, he engineered an AI/ML-driven remediation system that handled over 2 million automated fixes annually. And he's built distributed systems at companies like eBay, Oracle, and Nokia. My favorite fact about Suresh Mathew is that apparently he was on a call with his team where one of the teammates improperly muted themselves. So they got to hear the whole story, and they were looking at some code where they were identifying Suresh bugs. I don't think that means that he's not good at coding. I think it just means that anytime we find a mistake, we're all just going to collectively blame it on him. Sound like a plan? All right, Suresh Mathew, please come introduce us.
All right, that was a fun fact. In fact, it's a true fun fact. Today, I'm going to talk about just 2 happy moments at Sedai. So at Sedai, we generally are happy when engineers are happy. So last week, I got this message from a customer. And as you can see, there are typos there. It was a morning message. Apologies to the marketing team. It's not a testimonial. It's a true message from a customer. Two years ago, when we were talking about autonomy, the market was highly skeptical. I would be skeptical too. We were claiming that you can do operations without engineers in production. Now, this story is about a customer not just getting successful in his org, it's getting rolled out enterprise-wide. Generally, when these messages come, we celebrate as a team. That's what we did as well. Thank you. Yeah, the second moment was announced yesterday. We raised our B. Thank you to AVP for leading the round, Sierra, NVP, and Uncorrelated for participating. Again, this is just the beginning. We announced our vision to the market. You should have a self-driving cloud in your enterprise. It's my belief that every enterprise will have a self-driving cloud soon. But before we get there, let's talk about this conference. This is not about us. This is not about our vision. It's about you. By 5 p.m., I promise that all of you will be ready to really take your org to the next level, which is the next era of cloud. Now, as you can imagine, I was working with this cloud for the last 2 decades, and most of the promises that this made has been wrong. 3 key ones: simplicity, efficiency, and being able to innovate and not worry about infra. If you look at where we are today, costs are spiraling up. It is unbelievably complex. And that's where we are coming in and helping people manage this cloud autonomously. Again, there are tasks that engineers will have to do, they'll continue doing, but there are tasks that AI systems can manage autonomously. And the word is very important here. When you are automated, the decision is always, always taken by engineers. When we are autonomous, they can turn to an autonomous system and say, you learned, you acted, I'm innocent here. Whenever we have problems as engineers, we run to automation. That's what we did in this case too. And this is a typical Kubernetes auto scaling configuration. The key here is there is nothing auto about it. The configuration that it is asking for, the minimum replica, they don't know what it is. Max replica, no, I don't know what it is. Target CPU, how do I know? No, I don't know. Target memory, I don't know either. So engineers answer to all these 5 configurations as no, I don't know. But they are pushed to answer this. If you were to run on GKE, you have to answer this 4. That's where we come in and say, you don't have to, you write code. We got this. We learn and fill this in for them. This is where automated systems are also different. They ask you to give affinity on all these 5. It is hard for an engineer. They don't know what to do. That's why we built Sedai. Now, of course, the next step is, let me throw people at this problem. They hire a lot of SREs, a lot of engineers, and see how we can fix this. The biggest problem with that approach is risk. It is quite boring to configure your services. If you ask people to do that boring task, they are going to make mistakes. So 2 options failed. Automation failed. Manual stuff, yes, it failed as well. Now, that is why we have now a self-driving cloud. What it means is only one thing, safety. That's the only thing it means. You can now drive your car safely without accidents on the road. Now, if you look at automation here, right? Imagine you're driving a car, a biker is swerving off of the sidewalk to your road. How do you write rules to prevent it? You cannot. You have to just learn, you have to adapt, and that's how you fix it. That's why Waymo uses deep RL to figure out this and fix it and move the car forward. That's what Sedai does too. We look at what's going on, we do our RL on it, we deeply learn your application. We know it better than your engineers. Your applications are known to the models better than your engineers. And it's not because they're not smart. It's because they are smart. It is because they don't want to know. They don't want to know your CPU configurations. They absolutely are into creating things. They're building stuff. You are pushing them to configure all those things. That's where, as leaders, we have to really give that freedom to them to code, to build. That's where Sedai comes in and says, we'll take the configuration, we'll take the toil, you can continue building. Now, there is always this debate about, is AI replacing engineers? My answer is no. Like Waymo, you have to pick where to go. Your goals are always set by engineers. My affinity for this application is performance or cost, or at times even reliability or availability. That's generally non-negotiable, but you can configure that too. But that's set always by engineers. Once they set that, we take it from there. From place A to place B, we know how to take them. Now, the other usual misnomer is Can AI do everything? Answer is no. If you look at a pyramid of tasks, AI is always at the bottom of the pyramid where toil is there. That's where it helps. That's where things can be autonomous. The top of the pyramid is still engineers. The decision making, the smart stuff, the building, that belong to them. We handle the bottom, so they are free to do that. What we support today, we started with compute. We covered almost 90% of compute. We have a few on Google that we need to cover. Then we move to data. Now, data can be managed autonomously. And while we build these two, we made sure that the large enterprises can adopt it with all the features that's around it. Now, we are announcing a few things this week. The first one, Databricks. We now optimize Databricks. The second thing we were initially not focused on was a stateful cloud. We started optimizing that as well. So now your Kubernetes, if it's stateless or stateful, it used to be only handled by Sedai for the first part. Now we handle the second aspect too. The third one is GPU optimization. Of course, the right sizing aspects and parallelism is now handled by Sedai. This year, whenever you have an LLM-based system, one thing that happens consistently that we heard from customers is cost. The second is efficacy. And we figured out that LLM ops is something that engineers would expect a system like Sedai to handle. And that's in our roadmap. BQ is, of course, there. There is always a debate of building a billion-dollar company with one engineer. We append it with adding one more. We think a billion-dollar company can be built with one engineer and one SRE. This is Sedai Lens that we are announcing today. You can now talk to Sedai. You can ask it to build reports for you. You can reason with it, what is my most expensive application? Where am I wasting the most money? Where can I optimize? What release is causing this cost spike? It'll start answering all of those. For instance, if you want to go to a meeting with the leadership, you don't have to write the slides. You can ask Sedai. It'll bring the slides for you. Now, the most important question is, why does it matter for you? So this is the number of hours that we saved on average for an enterprise. So this time can be repurposed for developing things, building things. Of course, the cost savings, it can be repurposed as well. And if you look at the number of actions that we have done, is 25 million actions in production and 0 incidents so far. It is not an easy metric to project. How can you make all these operations without production going down? Because we are handling their infra, it has to always work. That is the beauty of an autonomous system. It will never make a mistake. It might stay away from an action. Mistakes, impossible. Unless you have bugs like Suresh bugs, of course. So why are we building this, right? The main purpose of this is to free our engineers up so they can really do the fun stuff. They can build things so we can work on the toy. That's why we built Sedai. Let's do this. Let's build a cloud where things are safe, it is efficient, it is autonomous. Thank you.
I just persuaded Suresh that he would answer a question or two if anybody had one. Are there any questions? Should I bring him back on stage? Excellent. There's one. Wow, watch how fast that hand went up. Come on up, Suresh.
Right sizing versus existing compute services. Can you?
I noticed that you have released GPU optimization and right sizing. And I'm just wondering, is there an approach there like memory bandwidth or memory consumption that is, what might that look like compared to, say, optimizing a traditional Kubernetes cluster or CPU, in a more general environment?
Got it. Thanks. Yeah, I got the question. So the first version of it is exactly like CPU. Right. So GPU is treated exactly like CPU. Then we start reading the metrics of GPU specific metrics. And that's where we started optimizing GPU for GPU. So the version that we have released now is the second one, where it considers both. Did I answer the question? Any other questions? Tim, you already know all the answers.
That's why I'm not asking you the question. The question goes to Suresh here.
Another Suresh, I'll get them.
So, Suresh, firstly, thank you for the great comments. And I think every CEO's dream is to have a customer like you that pushes them and supports them early. So I want to thank you on behalf of the company. So I'm going to use the analogy that Suresh Mathew used, which is the Uber to Waymo analogy. So quick story. I was in San Francisco just a couple of months ago, and I had the option of choosing between Uber and a Waymo. And when I jumped in the Waymo and made my 2-mile trip, it was just a no-brainer that if I had Waymo in my neighborhood, I'd use it all the time for all the reasons that we know. So my question is that it's so obvious that the experience is so much better in a Waymo, say, compared to a Uber. So what are the top 2 or 3 issues, technical or organizational, that get in the way of adopting autonomous? And you've obviously been through the journey.
Yes.
And this is more of an moving the pile forward for the industry. This is not a Sedai specific question. I'd love for you to elaborate.
Yeah, that's a good one, Tim. I think, one thing is, I think for the trust to be built, I think there's still an element of, like you said, until you jumped into the Waymo, you probably didn't realize how good it was, right? So it's almost like you almost have to trust it, to try it, and then, you start believing in it, right? And I think a lot of us have, I feel like over the last 2 or 3 years, we've gone through that experience ourselves in the use of some of this AI stuff. It almost looks magical, but then over time it gets normalized, right? And then you start, expecting it to do what it does, and you're no longer sort of as, amazed by it. It becomes more something you can trust and use in a regular manner. So I think what we are trying to do is to be very aggressive about driving a lot of these autopilot capabilities in our non-prod environments, because it's a safe place. It's almost like a sandbox. You can even afford to fail. As engineers try it there, they start, seeing that it's doing what it sort of claims to do. They can trust it, and then we slowly graduate it to the production higher stakes environment. So I think that's one big one. The other one is, I think, for engineers, like I said, there is an element where we rely on autonomy from services like Sedai, but then there are some sort of bespoke workflows that we want to make autonomous for ourselves. So as we build our own workflows, we see that it works, right? And then we see, there is sort of that existence proof, right? When you've built it yourself, you know that it is possible and it exists. And then, our sort of tight relationship with a company like Sedai, for instance, where we have access to the engineering team. The engineering team is on site, right? We're talking to them very directly, engineer to engineer. Then that trust develops, and then we are able to, really move to the autonomous mode. So it's a little bit of a journey, but I feel like, it's built on these elements, but these are almost necessary steps I think we have to take to get to autonomy. All right, thank you.